I saw that there were some troubles with different things doing with sectors, so I brought up some more sector practice. So in this question, I've given you the radius as well as the central angle. We're going to go ahead and find the sector area and the arc length. So I'm going to go ahead and do sector area first. Notice that sector area is everything inside here. I'm just going to lightly color over it. Everything on the inside is the sector area. Okay. So I'm going to notice here, I'm going to do sector area equals, and this is always going to be the fraction that you care about times the entire area. And that fraction that we care about is central angle divided by the full circle. Because this is in degrees, we're going to do 70 over 360. So 70 over 360. From here, we're going to multiply it by the entire area of the circle. Remember, area is done by the formula pi r squared. Our radius is 9, so pi times 9 squared. And I'm going to go ahead and start simplifying this. 70 divided by 360 is 7 over 36, because I've just divided top and bottom by 10. On the far side here, we have 9 squared is 81. So I have times 81 pi. That is an 8. 81 pi. And now I'm going to go ahead and notice that 81 is out of 9s. 36 actually has 9s in common. Let's go ahead and break that up. Maybe this would have been easier in the first place. So I have 9 times 4 in the bottom. And that 81, let's go back and leave it as 9 times 9. In this case, simplifying the 9 squared isn't necessarily easier. Because from here, notice what we can do. That 9 and that 9 are going to cancel. Here's what we're left with. 7 times 9, so I have 63 pi. This is a big 3, over 4. So 63 pi over 4, that is our area. This is in inches squared, because units were inches. But let's say you wanted it rounded to decimal places. So on my calculator, 63 pi over 4, 49.48. I'm going to come down below. This is approximately 49.48 inches squared. Okay, so that is sector area. The one in purple is the exact answer. The one in orange is the approximate. Now let's do arc length. And arc length is this stuff right here. It's the crust on the pizza. So this whole stuff here, that is the arc length. So I'm going to come over to here. I'm going to say sector arc length. And notice that we're going to use the same beginning, fraction that we care about times entire circumference. Well, the fraction that we care about is still 70 over 360. And our formula is 2 pi r for circumference. So 2 times pi times the radius of 9. Okay, let's go ahead and take a look at our next line. Switch pens here. Alrighty, well, I can do the same thing. I know that 70 over 360, divide them by 10. I have 7 over 36 times, and this time, remember, I learned from what I did over here. I could multiply together. 2 times 9 is 18. I could also separate them and just leave them as 2 times 9. The way you do that is up to you. I already know that 18 goes into 36, so I might as well use the 18. So times 18 pi over 1. And as I want to point out here, if I divide this by 18, I get 1. If I divide this by 18, I get 2. because 18 times 2 is 36. Go ahead and go straight across. I'm left with 7 pi over 2. And these units are just inches. Now again, let's say I want to approximate this. So I have 7 pi over 2, and that is 10.995. If I'm rounding to 2 decimal places, so that second 9, this 5 will kick it up, and that kicks everything up. When you round this, it actually becomes 11. So approximately 11 inches. Okay, so that's one of our examples with our sector practice. Okay, in this one, we have some sector puzzles. So this one says that I have 3 circles inscribed in a rectangle. It just means that these 3 circles are touching the sides of the rectangle. And we want to find the shaded area. That's the stuff in red. So those little parts are the shaded area. So to do this, we're going to have to do composition of shapes. We're going to have to subtract the circles from the big rectangle. So let's go ahead and do some labeling here. See these little tick marks? That means those circles are all congruent. Each of them have a radius of 4. So let's see what happens if we go do that all the way across. If I connect that all the way across, this tells me that all the way here, 4, 8, 12, 16, 20, 24, all the way across is 24, and we're just going to call these some kind of units. Looking this direction, 4, 8, these are 8 units. So that's what we're going to do to find our rectangle. So again, let me actually switch colors here. We want to find the area of the shaded. So area of shaded. This is going to equal area of rectangle. So area of rectangle minus the area of the circles. Now each circle is congruent. They all have the same radius, 4, 4, and 4. So if I find one of those circles, I have to multiply it by 3. So minus 3 times the area of just one circle. All right, now area of the rectangle, let me do that over here. Area of the rectangle is just length times width, 8 times 24. So 8 times 24, go ahead and grab a calculator if you need to. 8 times 24, 192. So this value here is 192, and this will be units squared. Units squared. So this equals 192. Let's do the area of the circle next. Slide this up. So area of the circle is going to be pi r squared. So pi times 4 squared, that's 16 pi. Remember, 4 squared says 4 times 4. So 16 pi. All right, let's do a quick recap of what we need to do. So to find the shaded area, we're going to do area of the rectangle minus 3 times the area of a circle. So the area of the rectangle was 192. I'm going to take away 3 times the area of the circle. So 3 times 16 is 48 pi. 48 pi. And I'm going to go ahead and put it in a calculator to get out the estimated value. So over here, I'm going to do 192 minus 48 pi. And I have 41.2. So 41.2. And this is in units squared. Let me go ahead and just write a little note up here. This one said 41.2 units squared. And this one here says 48 pi. I think that one is still readable. Okay, so now you have another example of how to work with sector questions as well as puzzle problems.